Now using division algorithm, I can find the GCD when the magnitude of the given numbers are too large. I can find the GCD using division algorithm called Euclidean algorithm. Euclidean algorithm is finding GCD using division algorithm, that's all. Using division algorithm, we are going to find GCD of given two bigger number, and that process of evaluating the GCD using division algorithm is called Euclidean algorithm. I will show you explain how exactly my Euclidean algorithm will go. So you can enjoy Euclidean algorithm in a tabular representation. It is Euclidean algorithm. Euclidean algorithm. So Euclidean algorithm is used to evaluate what? GCD. When I should apply Euclidean algorithm? When the given two numbers are too big. If it is very small, I can do in a classical way. Get the divisor, get the common divisor, take the biggest one, say goodbye. Now what is the procedure? This is B, this is A, and B should be always greater than A, starting point. Take the bigger one, call it as a B, smaller one, call it as A, and get the quotient, get the remainder. Now what am I supposed to do? You push in place of B, write A, in place of A, you write R. So pop up, eliminating, delete B, replace B by Q, replace B by A and A by R, follow the same procedure. I am going to get Q1, I am going to get R1. What is B? Dividend. What is A? Divisor. What is Q? Quotient. What is R? Remainder. Again, follow the same procedure. Pop up R. Replace A by R. Replace A by Q1. Replace A by Q1. Again, apply the procedure. Get the Q2 and get the R2. You follow this procedure unless your R becomes 0. You follow this procedure repeatedly, apply loop. Take the B, take the A, get the Q, get the R, replace B by A, replace A by R, get the Q1, R1. Again replace A by R and R by R1, get the Q2, R2. This sequential iteration or the process will be continued continue till you get R equal to 0. Once the R component becomes 0, the previous value of R is going to be GCD. Once you get R equal to 0, stop the process. You can write here stop. Go to the previous step. Get the R value. That is going to be GCD. I am going to show you one example how to evaluate GCD. And when I should apply Euclidean algorithm? I should apply Euclidean algorithm only when the given numbers are too big. And I should apply Euclidean algorithm to get the GCD. And Euclidean algorithm works only on the division algorithm. You know what is division algorithm? B equal to AQ plus R. Using that concept, using the division algorithm, repeatedly apply division algorithm till you get the remainder 0. The previous value of the remainder is going to be GCD, and this process of repeatedly applying division algorithm is going to be Euclidean algorithm. Euclidean algorithm works on division algorithm. Euclidean algorithm will be applied when the given pair of numbers are too large, and Euclid algorithms is used to evaluate the GCD of the given pair of numbers. I'll show you an example. I'll be ready with that because I cannot do everything here. GCD of the pair 450 and 741. GCD of 450, 741. The numbers are not simple. The given numbers are quite large. You don't apply my classical approach of finding GCD. You better switch over or move towards Euclid algorithm, where Euclid algorithm works because of my division algorithm. Now what is smaller value? 450. What is a bigger value? It is going to be 7. Always you start with this. Take the smaller number, call it as A. Take the bigger number, call as B. Always this is how the problem starts. Now construct a table. What are the components here? Here it is B, it is A, it is Q, it is R. What is the small B value? 741. What is A value? It is 450. 450. Now how to get the quotient? Everything I am ready with that. I don't want to waste my time. The quotient is 1 and the remainder is 291. That is, when you consider 741, we can write 450 times 1 plus 291. This is B, this is A, this is Q, this is R. Now, first level of division algorithm is over. My remainder is not equal to 0. I should continue. How? Remove B, bring A. That is, move here. It is 450. Remove A, bring R value, not the Q value. Bring the R value. It is going to be 291. Again apply the same procedure. What is the value here? 450 when you divide by 291. 450 when you divide by 291, the quotient will be 1 and my remainder will be 159. This is second level of division algorithm. Whether I need to stop? No, because the remainder component is not equal to 0. Again, move 291, move 159, again apply the same procedure. Here it is going to be 1. When you divide 291 using 159, your quotient will be 1 and the remainder will be 132. Third level of division algorithm. I cannot stop here because my remainder is not equal to 0. Again pop up 159, pop up 132. Again same procedure. So 159, 132, for this pair of number, your Q equal to 1 and R equal to 27. Again, it is the next level. To be continued? Yes, because my remainder is not equal to 0. Again do the popping. Again do the popping. Now again write. When you consider 132, when you consider 27, what is the Q value? It is 4. And what is the remainder? 24. Again continue. Call 27 here. Call here 24. It is going to be 1. It is going to be 3. Again continue. It is 24. It is going to be 3. It is 8. And the remainder is 0. Now here stop. Stop the process. Once you get the remainder 0, sequentially you are applying division algorithm with replacement of B and A. Retain in the first step, get the B, get the A, get the Q, get the R. Move A to B, move R to A, again process. Go till, repeated this process few number of times, few iterations, till you get the remainder 0. I got remainder 0 at the end. Now stop the process. Immediately I can write, see here, my GCD between the given pair of numbers 450 and 741. 450 and 741 we can write is going to be the R value previous to 0. Previous 0 value in the R column will be my GCD. My GCD is going to be, see how simple is it? Nothing we applied. We never consider the classical definition. Get the divisors, get the common divisor, then the biggest one. We never applied. We applied a very basic principle of representing a number using division algorithm in the form of AQ plus R. Replacing B and A suitably with the next iterational component. Procedure, process this, continue this until R becomes 0. Once R becomes 0, you can stop and go to the previous non-zero value in R. That is going to be my GCD. So beautiful, so elegant, so excellent, so simple looking. And what is the procedure we follow? See here, B equal to AQ plus R, 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 B equal to AQ plus R. Last component, B equal to AQ, no R. Once there is no R, go to the previous value of R, which is a non-zero value, and take, that is going to be your GCD. I can show you one more example and be thorough with this, because ultimately my number theory, linear, linear equation, Diophantine equation, then Chinese remainder theorem, and my cryptography, RSA cryptography, everything works on division algorithm, getting the GCD. So carefully you execute, understand the method of finding GCD. When the given numbers are very small, you go to classical approach. When the number is not that small, it is quite big, don't follow classical approach, follow the tabular representation. Each operation is a division algorithm. See, what do you mean by this? 450 into 1 plus 291, 741. 291 into 1 plus 159, 450. 159 into 1 plus 132, 291. 132 into 1 plus 27, 159. 27 into 4 plus 24, 132. And 24 into 1 plus 3 will be 27. 3 into 8, no more R will be there. Directly 3 into 8 gives you 24. So go to the previous one, draw the non-zero value of R, that is going to be GCD. I can go you one more an example. I'll take with bigger number. Yeah. GCD of, see, this is very bigger number, carefully see now. 25520 and 19314. 19314. Take the bigger as B, smaller as A. What is A? It is 19314. What is B? 25520. Now the numbers are too big. Your question is getting GCD. Never apply classical approach. Apply division algorithm repeatedly till I get the remainder 0. This is B, this is A, this is Q, this is going to be R. What is A value? 25,520. What is A value? 19314. Now what is the quotient? 3. What is the remainder? 690. Again I am going to explain. 2520 can be expressed as this into 3 plus 696. It is A into Q plus R, division algorithm. I didn't get 0. Go to next level. It is 19314. It is 696. Again division algorithm. I had a mistake actually here. It is pardon. It is 1. It is going to be 6206. Sorry. Now you consider 19314. Consider 6206. It is 3. It is going to be 696. Now consider 6206, 696. It is 8 and 638. Consider 696. Consider 638. It is 1 times 58. You consider 638. You consider 58. See the beauty now? It is 11 and it is going to be 0. Give a number B, give a number AQ plus R, I got the bigger number. Now move A in place of B and R in place of A. Now this number equal to this into this plus this number. And you are concentrating over R. Now I didn't get 0 here. Go to the next level. I didn't get 0. Go to the next level. I didn't get 0. Go to the next level. I didn't get 0. Go to the next level. I got 0. Now what is GCD now? The GCD of the given two numbers 19314, comma 25520 is equal to, you stop here, go to the previous one, it is going to be 50. See, beautiful. When the numbers are too heavy, when the numbers are too big, see these we can evaluate using calculator. If you have a scientific calculator, you can enjoy getting the Q and R with less difficulty. So I got the B, I got the A. I can find the Q using calculator, I can find the R using calculator. There is some technique is there. If you follow the technique, you easily can enjoy. I'll show you one such case. Okay, after completion, after showing how exactly I got the GCD when the numbers are too big, when the numbers are too small, original definition, when the numbers are too big, my original definition, classical approach is too tedious, but still it is possible, too tedious. Don't entertain. Go to division algorithm, repeatedly apply division algorithm called Euclidean algorithm to get my GCD. Finish. Now my question is, sir, how easily we can find, for example, these two. Sir, how I can find 3 and 696? I'll show you now. You be ready with a calculator. Is what I can call. See how to find. Say for example, I got 19314. I want A times Q plus R, or I can say what is A? It is 6206 times 3 plus 696. Sir, how I can find easily? Well, I need to scratch my head to find this? No. How to find? How to find? B with calculator. Scientific calculator. I'll show you now. Because whenever you learn everything in a very better way. Due course you can enjoy every technical applications through whatever you learned in a very systematic way. See, what do? You consider divided by 6206. When you divide 19314 divided by 6206, many don't know. They do in a classical way, but this is a very better approach. I can write here, I am going to get the answer 3.112149533. Calculator. Using calculator I got the value. Now this is your quotient. When you multiply these two, I am going to get the remainder. See now, 6206 multiplied to 0.112149533. I can show now. If you multiply by 6206, I got the answer 696. See? This is going to be Q. This is going to be your A and this is going to be your B. See how simple? I can show you one more. So 19314, see here, 19314 is this times this plus this, A into Q plus R. How to find the Q and R using scientific calculator? Very simple. Divide the given number, bigger number by the smaller number, get the integral part as a quotient, take the decimal part multiplied by the divisor to get my remainder. I'll show you one more. I'll show you this case now. So I can say I want 6206, I want to express 696 times 8 plus 638. So it looks simple. When I write, it looks simple. But when you evaluate, it takes too much time. Minimize the time using calculator. What I am supposed to do? You consider these two. 6206 divided by 696. 6206 divided by 696. I got 8.91, so many 6 times 7. This itself is Q, and when you multiply, I am going to get the R, that is 696 multiplied to 0.91666667. Do it now. I got 638. Six 638 is my R and 8 is my Q. 696 is A and 6206 is going to be. So I can write here B equal to AQ plus R. This is the easiest way using calculator to get the R and Q value. So evaluate, see the numbers are too big. This is very bigger number. My classical utter fails. You cannot find all the devices. Sometimes you may miss some devices because the number is too big. Best approach is Euclidean algorithm. Euclidean algorithm is a sequential division algorithm, but with a proper movement, proper replacement. You stop once I get remainder column. Remainder column would become 0. You stop the process, go to the previous non-zero remainder, and that is going to be a GCD. Easiest way of finding. Now my question is, Sir, what to do with GCD? What is the special property of GCD? If you have the GCD of A comma B equal to G, carefully see now, carefully listen. This is the next level and most important level. If I know the GCD of A comma B equal to G, then always we can express in this form. I can express my GCD using the given two numbers with the proper scalars. So we have x comma y, both are integer, can be positive, can be negative. X and y can be positive, can be negative. Both can be negative, both can be positive, one can be positive. Generally, one will be positive, both will be positive, or one will be positive, one will be negative. Both negative never arises because G is always positive. So, x and y both can be positive. X or y, it can be positive as well as negative. One will be positive, one will be negative, or both will be positive. Both negative never happens. This is called a linear combination. This is called linear combination. This is the ultimate work. Only when you understand the linear combination representation, can you see here? It is a linear combination. Every GCD can be expressed as a linear combination of given two numbers, where the given two numbers for which you are finding GCD. I got the GCD G for the numbers A and B. The same G using A and B I can express. G equal to AX plus BY and not unique. It is not unique. How to get the many linear combination? Many linear combination. LC means linear combination. We can write G equal to A into X plus B into Y. Carefully see now. A into X plus B into Y. Already have one combination. You consider N into AB, consider minus N into AB for different values of N. So what we can do here? I can write A as a common to get X plus N into B. Here I can take B as a common, Y minus N into A. For different combination of N and N, I can find for different values of N, where N will be over integer. It can be 1, it can be 2. If it is 0, my original primitive linear combination. If it is not equal to 0, any positive value of N, it is strictly better you take positive value. Then I am going to get the next level of what? Linear combination. See, there is beauty. Primitive level. Primitive level. People have heard of cryptography. Coding and decoding. When I say coding and decoding, the next question is, what is the level of security? For the better level of security, I should go to the higher level. To go for the higher level, this representation plays an important role. It is a basic level. Take N equal to 0. First level, I want first level security. A hacker should have some difficulty to hack, then take N equal to 1. I want, say, 10th level. 10th level, it is like this. You take a smaller circle, first level, second level, third level, fourth level. I can go to 100th level. This easily you can break. This is okay, you can breakable. When we go to the 100th level, 100% it is not that easy to break your security value or security or security level will be too high when you have higher level of linear combination representation. That is a beauty, and ultimately what basically what you are doing here, application of number theory you are dealing. The next phase of next phase of the classes will go with only application. What is linear equation, what is a Diophantine equation, what is Chinese remainder theorem, then what is your cryptography, RSA cryptography. We can go till that extent. Okay. And let's see how much possible today I can do it, and later. Now my question is, you understood how to find the GCD. See, GCD can be evaluated. GCD can be evaluated. GCD between the two numbers can be evaluated using two approaches. One is classical definition. Another one is division algorithm. Sequence of division algorithm is called Euclidean algorithm. Euclidean algorithm. When I can do this, numbers are too simple. My sincere advice is never go to classical definition, always stick on to division algorithm, that is Euclid algorithm. Maybe a simple number or complicated, you can do easily with using the scientific calculator. Now once you got the GCD, what is the next level I can think of? Is it possible to express the GCD as a linear combination? Yes, that's what I wrote here. G can be represented using AX plus BY. A and B are going to be are given number. G is the evaluated GCD value. X and Y you are investigating. But that X and Y are not unique. How to make many such combination or higher level? Introduce n into AB, introduce n into AB where n is any integral value, preferably positive. And AB, take the product of A and B, multiply some number, add it and subtract, add it, then subtract. When you are adding, take the A common. When you are subtracting, take the B common. You will get the higher level linear combination. When you take n equal to 0, my primitive linear combination, n equal to 1, 11, 1 combination, n equal to 2, level 2, n equal to 100, level 100 linear combination. Once you go to the higher and higher level combination, it is too difficult to guess what is your A and B value. That is why we got cyber security, coding and decoding, high security component. It can be done easily with going with higher level linear combination of GCD. I will show you one example how we can do linear combination. The question is like this. I told you how exactly we can go. Find GCD, hence find linear combination. I'll write linear combination. This is called linear combination. What is G? I investigated. What is A and B? Given two numbers. What is X and Y? You are investigating. You are investigating X and Y in such a way that when you consider the combination of AX and BY, linear combination without any power, AX and BY, their algebraic sum will be my G. And which is unique? No. I can have many such values. I'll show you an example. GCD of 486 and 434, 486 and 434, find linear combination. It's very simple. You consider smaller number A, that is 434. You consider bigger number B, that is 486. You know how to write this table. What is this component? The bigger value. What is this component? Smaller value. What is this? quotient. What is this? Remainder. Extra one column is there. This extra column for linear combination. Now, if the linear combination is not required, you can stop here. If the linear combination is required, you can go with one extra component. Here we can write R equal to B minus A into Q. Simple. Tabular representation is very easily can enjoy. Now we have 486, we have 434. It is 1, it is 52. See the formula simply you can write. It is 52 equal to 486 minus 434 into 1. See, B minus A into Q. See, I did get 0. One more iteration. 434, 52. Again the value will be 8 quotient and the remainder will be 18. I can write my 18 can be taken as 434 minus 52 into 8. Still I didn't get 0. One more iteration. 52, 18. No, not it's 18. I had a mistake actually. 52, 18. Yeah, fine. Yeah. 52, 18. It is 2 times, it is 16. And we can write here 52 is equal to, 16 equal to 52 minus, see the formula, it is equal. 52 minus A into Q, that is 18 into 2. Still not equal to 0. Try one more combination. What is one more combination now? So consider 18, consider 16. Simple mathematics. It is 1, it is 2. We can write 2 equal to 18 minus 16 into 1. Still I didn't get 0. Try one more combination. It is 16, it is 2, it is 8, it is 0. I got the 0. We don't want this. Now how to get the linear combination in an easier way? See, you learn the mathematics in a very shorter and simple way. So then only I can think of next level application of mathematics into my technical domain. If you make mathematics is very hard and long running, your energy will get decayed. Now this is a shortcut method. Now you go, what is GCD now? GCD of the given numbers 434, 486 is equal to, what is the 0 previous number? Is going to be 2. I got the GCD of the given pair of number 2. Now question is linear combination. Linear combination and not unique. I want to prove both here. You move upward direction. You move upward direction. Just take this value. 2 equal to, carefully listen now, 2 equal to 18 minus 16 into 1. Now go to the next level, 16, replace 16 by this value, that is 18 minus 1 into, I can write here 1 into, I written the other way, 1 into 16 we can write 52 minus 18 into 2. Simplify, 18 minus into minus plus 18 into 2. We can write 18 into 3 minus 1 into 52. Now this is over, this is over. Now replace 18. We can write 3 times your 18 value, we can write 434 minus 52 times 8 minus 1 into 52. Now again simplification equal to 3 into 434. Nothing can be done. Carefully see now. Minus 52 times 8 minus 50 times 1. That is minus 8 times 52 minus 1 times 52. Simple. Minus 9 times 52. We can write minus 9 times 52. Now replace 52. So we have 3 times 434 minus 9 bracket. You can replace 52. 52 we can write here 486 minus 434 into 1. Now 3 into 434 minus into minus plus 1 into 434. We can write 4 times 434 minus 9 times 486 minus 9 times 480. This is also. Now back substitution, reverse process stops. Now we can write equal to a into x plus b into y. How? We can write here 434 times 4 plus 486 into minus 9. I am putting in a very standard format. 434 into 4 plus 486 into minus 9. Now we got 2 equal to a into x plus b into y. A and b already given. A and b already given. G evaluated as GCD. Now what is x and y? Your x is the multiplier of a, that is 434. That is going to be 4. And y is the multiplier of b, that is 486. It is going to be minus 9. Now I got the linear combination. I want non-uniqueness proof. Very simple. Equal to ax plus n into ab plus by minus n into ab. 2 equal to, I can take a common, nb plus y common. We have not y common, it is b common. We have y minus n into a. So you can do it now. 2 equal to a times, what is x value? It is 4 plus n. You can take any value of n and directly write n. What is b value? What is b value? B value is 486. We have 486 plus b into, what is y value? Minus 9 minus n you retain. What is a value? 434. It's going to be 430. Take n equal to 1. Next level. Take n equal to 2. Next level linear combination. Take n equal to 100. 100 level linear combination. Take n equal to 1000. 1000 level linear combination. So higher level linear combination plays an important role when you go with your, particularly your crypto system coding and decoding in a high level secured way. Hacker should not hack. He is too difficult to guess what level. So according with that regard, don't always go with a level 1, 0 or 1. Go to higher level. Higher level, you can write the formula. You want 100 level. Take n equal to 100. Take n equal to 100. Directly you can go to 100 level. That's how we can think of. Okay. Now we have, this is a prerequisite. I told you what are the prerequisites. The prerequisites, again I'll go back and I'll, basic number theory, divisibility, prime, relatively prime, unique factorization, greatest common divisor, division algorithm, Euclidean algorithm, extended, this is called extended Euclidean algorithm. This is extended. This is Euclidean algorithm. So, Euclidean algorithm, extended Euclidean algorithm to get higher level linear combination for my better security. Now the next important application, or I can say the basic required, still we never enter into the main topic of the application part of number theory, that is a linear congruent, then we have Diophantine equation, applications are there, Chinese remainder theorem, Fermat's little theorem, Euler's phi function, Euler's totient function, and your cryptography, RSA cryptography. So I may require one more session for that. I will explain modular arithmetic, I will put a break. Okay. Now we have modular arithmetic. Now have a recall. Number, we have natural number, integer number, then we have primes, then we have composite, then every composite has a product of prime unifactorization theorem. Now you consider pair of numbers, get the GCD. If the GCD is not equal to 1, they are not relatively prime. If equal to 1, they are relatively prime. That's all. Don't scratch much with relatively. What is relatively prime? You evaluate the GCD. If the GCD is 1, relatively prime. GCD not equal to 1, not relatively prime. Then linear combination of GCD and non-uniqueness. This is what exactly we studied till now. We are going to the next level called congruent modulo class. This is very important. Congruent modulo class. Again, everything we are going to play with integers. Let A and B be any two integers. M greater than 0, B a divisor. Actually, a divisor should be always an integer. We are always dealing with integer. At no instead of time we think of fraction. Always we consider integers. Now what do you mean by this? I got two numbers A and B. M is going to be a positive integral value. You consider A minus B. Consider A minus B. See the procedure. To define modular class, what exactly we are doing? Take the difference of given two numbers. Consider, I can write here, consider A minus B or B minus A or B minus A, any one of them. Don't get confused, both are valid. Now we have two approaches. M divides A minus B or M does not divide. See, again we are going back to divisibility. M divides A minus B and M does not divide A minus B. When M divides A minus B, then we call congruent modulo. In this case, we call congruent modulo. Here we say not congruent modulo. See, the previous level is a very smallest level. I took two numbers, divide, don't divide. If you don't divide, I am going to get the remainder. Using that I got GCD, common divisors, greatest common divisor. But here the complexity grows more now. So milk everything once or twice. Consider A and B any two integers. ಎರಡು ಸಲ ಹೇಳ್ಕೊಳ್ಳಿ ಅದನ್ನು milk ಮಾಡಿ. Take another integer m greater than 0. Say it is a divisor. Consider the difference of the given two numbers a and b. Either a minus, difference means either a minus b or b minus. I took the a minus b case here. I got a minus b. I got m. Only two possible cases. M divides a minus b or m does not divide a minus b. M divides a minus b, then congruent modulo. Not m does not divide a minus b, then it is not congruent modulo. Understood? Very simple. I can show you an example. You consider a equal to 10, you consider b equal to 3, and consider m equal to 2. Carefully observe now. What is the procedure? The procedure is take a minus, what is a minus b? 10 minus 3, I can directly write 7. Now we have two tracks are there, two approaches are there. See whether your m divides a minus b. If m divides a minus b, you are happy to say I am in a congruent class. If m does not divide a minus b, sir, namaskara sir. ಚೆನ್ನಾಗಿದ್ದೀನಿ ಸರ್ ಚೆನ್ನಾಗಿದೆ ಸರ್. ಸರ್ MIT ಕಾಲೇಜಿಗೆ ಬಂದಿದೆ ಸರ್, ಯಾವುದೊಂದು ಸೆಮಿನಾರಲ್ಲಿ ಟಾಕ್ ಕೊಡೋಕ್ಕೆ ಬಂದಿದೆ ಸರ್. ಅಪ್ಲಿಕೇಶನ್ ಆಫ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಬಗ್ಗೆ ಒಂದು ಹೇಳಿದ್ರು, ಹೇಳ್ತಾ ಇದ್ದೆ ಸರ್. ಹೇಳಿ ಸರ್, ಏನಿಲ್ಲ ಮುಗೀತು ಸರ್, ಹೇಳಿ ಸರ್ ಏನು. ನೋಡ್ತೀನಿ ಸರ್, ಖಂಡಿತ ನೋಡ್ತೀನಿ ಸರ್, ನೋಡ್ತೀನಿ. Take A, take B, take M. Simple. See, mathematics is generally simple if you understand in a very lucid and in a flow fashion. Take the A minus B, I got the 7. Now I have two options. This answer, whether your M divides or not. In this case, 2 does not divide 7. That is, M does not divide A minus B. Not congruent. The name congruent is very scary, but not at all scary if you understand in a very systematical way. I will take one more example. You consider A equal to 20 and B equal to say some 5. Take M equal to 3. See, the process is same. Logic is same. Take 3 numbers. A, B, M. What is M? Divisor. Keep it aside first. What is the process? Get the A minus B. What is A minus B? 15. I got the difference answer is 15. Now call back that M. Clearly 3 divides 15. Therefore, that means what? M divides A minus B. This implies M divides A minus B. Therefore, congruent. That's all. That's all. No much scary when you go with a congruent. Congruent will be using 3 numbers. A and B and M. M comes later. Take 2 numbers A and B. Take the difference. Adana artha madkoli. Take the difference. That answer, call M now. Divides, congruent. Don't divide, not congruent. If it is congruent, if M divides A minus B, if M divides A minus B, then we call congruent. How to represent? Then congruent, I can say. Then how to represent? Very simple. A is congruent, 3 lines. B mod M. That's all. Learn the other way. if A is congruent to B modulo M. What do you meaning of this? What I did actually? I took the A, I took the B, I took the difference, then I called M and he says I can divide. So that means M divides A. Learn both the way. So the next session I will take the properties of congruent, then I will directly go to my three important components. One is a linear congruent, Diophantine equation, Chinese remainder theorem, and maybe last 10 to 15 minutes I will explain how my linear congruent, how my Diophantine equation, how my division algorithms can play in and around my technical subject, basically cryptography. Okay, thank you.